Hey there, everyone. Welcome in. We're going to get started here in just a minute. While we're waiting on everyone to join us, please let us know in the chat where you're joining us from today. I'm Leah Houston. I'm a senior campaign specialist here at DBT Labs, and I'm very excited to be kicking off today's event, Build Reliable AI Agents with the DBT MCP Server. And I've got my kitty here as well. She is excited to be kicking things off with us today, too. Alrighty. Before we begin, we'd like to talk to y'all about Coalesce, which is the premier analytics engineering conference. It's crafted by DBT Labs and it's coming up here in October. So we hope that you can join us either in person in Las Vegas or for Coalesce Online. And Coalesce Online is totally free. You can register with this QR code or we'll drop a link in the chat for you to register that way. But yeah, I hope that y'all can join us, especially for in person in Las Vegas. It's super fun. It's a great networking opportunity. The sessions are really fantastic. We're going to be dropping the agenda here soon, so be on the lookout for that. And I hope that we'll see you in October. Some housekeeping things. We've got the Q&A tab. Please use the Q&A tab for all of your questions, and a DBT product expert will answer them for you. We also have the chat tab. That's where you've been letting us know where you're joining us from today. So continue to use that and have some fun with us. Etiquette. Please be kind to your fellow attendees and presenters. We want you to ask the tough questions, share feedback. We're glad you're here, but let's keep it respectful and inclusive. Recording. Yes, we will be sending out today's recording within 24 hours after this event wraps. So be on the lookout for that in your email inbox. And then we're going to launch a survey in the chat towards the end of today's session. We'd really appreciate it if you took that survey and let us know how to improve these sessions for y'all in the future. Today's event is part of our DBT Launch Showcase series. So we had our first episode back in May. That was our big 2025 DBT Launch Showcase spring product launch. So if you missed that, you can still catch it on demand. We'll drop a link to watch the recording in the chat. And then episode 2 was back in June. That was on modernizing self-service analytics with DBT. That is also on demand. You definitely want to catch that, and we'll drop a link in the chat for you to catch up. And then today is episode 3 on building reliable AI agents with the DBT MCP server. So thanks so much for being with us today. And with that, I'm going to pass things over to our presenters to really get started. So over to you, Tom.
Thanks, Leah. Hi, everyone. I'm Tom Grabowski, AI Product Manager at DBT Labs. Also joining me today is Igor, Head of AI at Indicium. So let's review what we're going to be talking about today. There's a lot of excitement around AI-driven analytics and how data teams can leverage Model Context Protocol, or MCP, for their AI agents. First, I'll review the role of structured governed metadata in building reliable AI agents and how teams are using DBT MCP Server to provide trusted context to agents. And then my friend Igor is going to showcase how his team at Indicium built an AI migration agent using DBT MCP, along with a demo of their migration agent. Before we dive in, I want to take a moment to define what we mean by structured governed context and why that's so important if you're working on AI agents where you want to include your structured data. It's common knowledge that LLMs can hallucinate. They can make mistakes, they can make up data, they can sometimes even introduce security risks. LLMs need to be grounded because they're just probability models that try to guess the right pattern in the response, and they predict what sounds right based on their training data. But they're not grounded in your business logic or understand your data's context. That's where structured context comes in. Structured context is that layer of governance that defines how your data is modeled, tested, and interpreted. It includes things like lineage, so knowing how the data sets relate to each other, versioning, testing, metric definitions, SQL logic, personal identification tagging, and other reusable components. All of that context tells an AI system just what data, not just what data exists, but how it's connected, what it means, how it should be used. It's what makes the difference between an AI that's just guessing and one that's giving you accurate, trustworthy answers. By giving your AI agents structured metadata, you're essentially giving them a playbook they can trust. It unlocks 5 really important components. First, It helps the agents truly understand your data and business logic. So they're not just guessing what revenue or customer ID or account means. They have access to your models, joins, metrics, so the outputs they generate are accurate and aligned to how your business actually works. Second, it helps them stay on track for multi-step workflows. Because agents understand how data is connected, they can help follow the right path without breaking things downstream. Third, it improves memory. When agents learn from clean, governed examples, gives them an example to follow instead of just making things up. Fourth, it lets them reuse SQL logic that's already been verified. So instead of starting from scratch, you can pull from version-controlled models, macros, and definitions you've already built in dbt. And finally, it gives you an audit trail. With lineage and version control, you can trace how decisions were made, validate results, and fix issues fast, whether it's broken SQL, a failed test, or a number that suddenly looks off. You can figure out what happened, or you can have the agent figure out what happened and fix it fast. At TBT, we already have the structure that AI agents need. Our users already define models, relationships, and metrics, all in version controlled, documented, and tested code in dbt. And with the launch of dbt MCP, we can now expose that structure for AI agents in a way that's usable, safe, and in real time. That structure foundation unlocks a wide range of agentic capabilities that allows agents to plan and execute workflows and generate SQL or documentation based on existing models and tested logic. It allows agents to reuse logic, share context, collaborate, and interoperate reliably. Agents can answer business questions using metrics and definitions from dbt's semantic layer, so the answers they return are correct and reliable. And as your AI stack evolves with new models and tools and interfaces, your structured foundation can stay the same as dbt. By centralizing logic in one layer, you reduce compute, cut down redundant queries, and get faster results. Now with dbt's MCP server, the structured foundation is fully accessible to AI systems through a standard open protocol. It brings everything together that you already had in dbt, your structured metadata, your dbt compiler, the metric flow query engine, and compute integrations, makes it all available to AI. Agents can now discover data, query the semantic layer, even execute transformations at scale. So just to recap, why is dbt MCP the key to unlocking reliable structured data in your AI applications? Because it delivers fewer hallucinations, faster development, stronger governance and security, and trusted outputs that can actually scale with you. And with that, I'm going to hand it over to Igor, who's going to walk us through how his team has used dbt MCP to build a migration agent. Over to you, Igor.
Thanks, Tom. I'm really glad to be here and really excited to talk about AI agents with you. So, first of all, let me introduce myself. My name is Igor Beninca. I'm the head of AI here at Indicium, and I have a little bit of commercial stuff to talk first, and then we can go to the demonstration, a little bit of theory as well. So, Indicium, right? We are a US-based company with more than 8 years of experience with the modern data stack and also with dbt. We have more than 400 dbt experts, certified experts. So it translates this into that we are one of the top global dbt partners, certified partners. And we have a lot of experience. We have done already more than 400 dbt projects. So basically we love dbt here at Indicium. We have a lot of experience with, and it's a pleasure to talk today with you guys about dbt and this agentic workflow. Okay, today we're gonna talk about migrations, data migrations. And to talk about this, let's first understand the philosophy behind this, right? So everything starts here from left to right. We have a legacy data system that we want to migrate to a modern data system, right, like dbt. And to do this, we need to map and convert all the data objects that we have in this legacy data system, not just data objects, but like the architecture as is, right? The relationships that these data objects have through other data objects. And this is kind of like an assessment, right? I need to understand everything that I have to then map and then convert this to a specific target data system, in this case, dbt. And to do this, you need to understand your target data architecture, right? You need to understand how a dbt project should look like. And this kind of task of mapping and converting, it's really tough. So it's repetitive. And this rings a bell, right? Oh, I can use AI agents to do this. I can use LLMs. I can use AI to map this and convert, translate this into dbt models. And normally you can just like do like a lift and reshape. You can do like you can already modernize this to like a star schema or another architecture or methodology that you want to. And to do this, right, to map this and then convert to this target data architecture, you need context. And that's when Indicium comes to the game. So you need for this context, you need experience. And that's what we have, right? I already explained this. We have done a lot of projects, a lot of dbt projects. We have certified experts. We have the idea, we have the concept to create a dbt project. So we know how this target system should look like, correct? We know that a dbt project needs those kind of best practices. We know that the LLM or the AI agent is not going to create trash. We know that the AI agent should create this dbt project with this process, with this way of working, right? So we can create this in a robust way. So having this in mind, having that we have this context, we know how the target data architecture should look like, we can map this and convert this. So we gather around and then creating agentic workflow to perform this, to have this done. And that's one of the most important things that we're going to talk today. So I really need your attention here. And let me explain the agentic workflow we have created here in Indicium together with dbt MCP to perform this map and convert migration. So left to right, okay, guys? So first of all, we have the legacy data system, and we need to map everything that it has there. And to do this, we have created this assessment agent. So we map everything and then translate this information into a knowledge graph, something I'm calling here this legacy data lineage. And knowledge graphs are really cool because I can map relationships. I can say that one table depends on another table. I can say that this table has a relationship with a specific notebook or a specific workflow. I can give more information. I can give relationship to this. And this is really, really powerful to LLMs, to AI agents, because this kind of context is in words. It's information that I can map this and give this to LLMs. And that's what we're doing here. So when we use the assessment agent, we have an output that is sometimes like a JSON or even like a Jira tasks, Jira ticket tasks, or even like a Google Sheet, for example. And when we do this, we pass this information to our master planner. Master planner you can see as like a project manager. We're gonna map this and see the complexity of each one of these data objects, all the dependencies as well, and see if we can divide this into different waves. Oh, for example, this first wave, we're gonna attack something more complex. And then we can decide, oh, these complex tasks, I can give just to like a senior analytics engineer. If the task is a little bit more easy to work with, we can pass this to like a agent, right? We can pass this to our planner and executor agent. And in this case, our planner, it's gonna perform the following task. It's gonna take this wave or this table that I want to migrate and then map basically everything, all the dependencies, all the code, all the information schema, all the things that I need in detail to execute this and migrate this to dbt. And just to illustrate this, for example, I'm going to migrate some March table, some Go table. I'm going to map, oh, this table needs 4 stages, all the business logic, everything, basically. And this kind of information is then saved into a memory, and then the executor can use this to migrate this and perform each one of these tasks using dbt MCP to test the models that is being created, audit these models, run, parse, compile, everything, basically everything that dbt MCP allows us to do. And this workflow for planner and executor, we have created an MCP here at Indicium to perform this. And I'm gonna demonstrate this to you in a minute. So just to summarize this workflow, and then we can jump into the demonstration, let me summarize this again. So we have a legacy data system. We're gonna map this and bring this information to knowledge graphs, which is really powerful to AI agents, LLMs to work with. And then a master plan is going to divide this plan, all these data objects into waves that I want to migrate, right? Some of the dependencies as well, some of the complexity as well. And then the master plan is going to take this and create like specific tasks. Oh, this table that I want to migrate and has these dependencies. I need stage models, I need intermediate models, I need those March tables, I need those kind of business logic to perform this, and then save this in the memory, and then the executor is going to use this to like open files, create all the dbt models together with our MCP, and also using dbt MCP in this case to run the models, compile, parse, and then have my target data system ready in production to use for all my business users, technical users, and so on. So now let me break down one of this agent's workflows to you. I'm going to start with the assessment agent. How can we perform this? So I have this legacy data system that I want to map this, and how can I do this? I can do this in three different ways. One is using the control plane for this legacy data system that you have, all the information schema data, like those kind of data that you have in the specific control plane. You can use even the repository, like the legacy ETL or ELT repository that you have for this, and also like data governance tools, like some catalog of your data. And the goal is to have this thing that I have here on the right side, this knowledge graph, these relationships. I'm showing here a relationship between like a gold table and other bronze tables. And I'm using this depends on relationship. And when I click one of these nodes, I can see everything, like all types of information. In this case, I'm showing like the information schema. Oh, this table has like this column that is a long type, it has a string type, and so on. So I can have all those kind of information to use this to my LLMs and then perform these migrations. And I can even have the code for this. And this is the first part. So this is like all the memory that I have in my system, so I can pass through my planner and my master planner to have plan tasks for this. And then I have another workflow, which is this plan and executor workflow, what I'm calling task manager, where we have our MCP, and together with dbt MCP, it becomes really powerful. And this agentic workflow performs the following thing. It's a plan task workflow. We can plan the tasks, execute the tasks, right, and then write the models, validate the models with dbt audit and dbt MCP, adapt to the results, and also verify the tasks. And to do this, we are calling the special sauce, right? We have the structured context. We know how a dbt project should look like. We have the dbt best practices. We know how to create a documentation test because we have this in our knowledge graph. We have this information. And in the end, we can also audit this model, see if the model is the same as it was before in my legacy system. We're using Audit Helper, is a dbt package for this, and allows us to have like a match in different levels, like in the complete table and also in a column level, which is really cool. So this is a little bit of the context. Let's jump into the fun stuff, right? I have a demonstration. I have recorded this because I need to speed up a little bit of the phase, because if I didn't speed up, it's gonna take like a long time. It's gonna be really boring. So I have recorded, but I'm gonna voice over this to you guys. So for the demonstration, I'm gonna use Cursor as my MCP client. And we have two custom modes, which are the agents we're gonna demonstrate today. One is the task planner, the other one is the task executor. So as you can see, we have an empty dbt project here where we have only 3 models, which is the audit ones. And those one here, it's the models that we're going to use to audit the legacy tables with the new models we are going to be creating. And we have 2 of them. One is for the completed table using a primary key, so we can see like a completed match. And the other one is in column level, so we can check for each one of the columns if we have something wrong. And the first thing we're going to do is to call our task planner and plan the following task. We want to migrate all the PySpark notebooks that we have in a specific folder in this project. It's in an auxiliary, this is in a support folder. So we're going to call all these bronze notebooks that we have inside there and migrate those to dbt. And we're going to use dbt MCP to validate and run and test all the models possible for this migration. And we're going to use Task Planner for this. So let's call the Task Planner. And the Task Planner is going to call 3 different tools. The first one is Analyze Task. We're going to analyze this task and then use this context to reflect on this so we can then create the tasks. And the last tool is Split Task. We're going to split this into different tasks and then we're going to write this down into some kind of memory and then use this later for the executor. So the Task Planner has finished and we can check all these tasks, these 5 tasks it has created. And you can see here, for example, analyze, implement, and you can see the 5th task is to run and test all the models using dbt. And we have this from change here where we can see the goal for the specific task that I give, and then it's divided into different 5 steps. And the first one is analyze, second one implement, and then the third one create all the documentation, creating audit models, and then the last task, as I said, is running with dbt MCP and check if everything is okay. So now we can switch to the task executor and then run one by one, right, with the right dependencies, the tasks we have just created with the planner. And the first one is to analyze. So it's going to call MCP to execute the task, or MCP, Indicium MCP. And it's going to analyze everything that we have in these different files. It's going to use our knowledge graph MCP to gather the information, all the information schema, all the columns related to the specific bronze files, the PySpark notebook files, and then create another memory, which is going to be the steps. For example, the following file that is going to create. Let me speed this up. So here we are. We are creating this memory file where we have almost everything that we need to migrate these bronze files to dbt models. And then we can check this as completed, and we can go back to the front end and see, well, we have completed the first task, which is analyze, and then give this as a plan for our next task. We analyzed everything, so we can move to the next task. And then we can proceed this. We can start the implementation. And the implementation itself is going to create all the dbt files needed for the stage layer, following the best practices, following the plan that I have just created with my planner, and also the memory. As you can see, I have called execute task. And now I'm going to start implementing all the dbt models following a SQL style, following best practices of creation of the stage layer, and also using dbt MCP to test a few things and parse a few of the files and check if my SQL is correct. And the first thing is creating the source file. And as an analytics engineer myself, I always hated this part. So creating all the documentation related to the source is always something that I leave behind and I do in the end of the project. And now with this agent is one of the first things that we do because we have the context that we gather from our MCP, our knowledge graph MCP. And then I have all the descriptions, all the columns needed for my stage files. As you can see, this is the first one, stage region. And we have here all the SQL being generated, following best practices, following the code style that I'm instructed my agent to create. I'm going to speed this up so we can see the creation of all stage files related to the specific folder, this bronze folder that I set to the agent, and then we can see the other part of the creation. So all the files being created, we can check each one of this, all following the best practice as I said, and then we can use dbt MCP again to call the compile and check if everything is okay. It's gonna take a while, so I'm gonna speed this up again and we can check later if everything is okay. Now I'm calling run again, just to check, double check, right? Safe is safe, double check this and have this pass to the next task and then have this completed. So our dbt run is completed. And just to check and show you the results, I'm gonna run, I have an instruction into my executor as well to show the run of each one of the models, just to some kind of compliance, right? To show you guys that it's completed, successfully run, and then we can move to the next task. And then in the end, I'm gonna call dbt show, again using dbt MCP, just to check if the results are correct, and then finish this and move to the next task. As you can see, dbt show ran, and we then can verify task and move to the next one, which is creating all the documentation, creating all the tests related to the stage files we have just created. And again, I'm gonna prompt here to start the next task. Our executor is gonna see our list in our memory and then move to the next task. As I said, creating documentation, creating all the tests. And you can see here that we have created stage region, the stage nation. We're creating for each one of the stage files. So everything is completed. Now I'm gonna call dbt MCP again, which is really, really easy to install, really easy to use. And I'm gonna call dbt test, check if my models are with the correct test, if I have the right results, and then move to a terminal again, just to show you guys that we are having the same results as we have in the MCP, just to illustrate this. So here's the terminal, just to check everything is okay. Same results as I had with the dbt MCP using the test tool, and show you guys that we have the same thing. Just a compliance, right? A compliance verification. Now I'm calling dbt docs just to check and create all the artifacts that is related to this last run. And then calling verify task again to finish this up and then moving to the next task. So until now, we have created the dbt models, we have created all the tests, we analyzed this, and now we can move to the fourth task, which is creating all the audits. So I have this instruction. Then we're gonna use this dbt package called audit helper. We're gonna see then if the results that I have with the models I have just created are the same that I have with my legacy tables. And we're using this dbt package called audit helper for this. And there is an instruction for my executor agent to follow this pattern that we have created here at Indicium, and then use dbt MCP to run these models and also check the results. As you can see here, it's creating all these dbt models which are for the auditing. As I said, first it's the model number one, which is a validation for the entire table, so we can see matches between those tables. And the second one is related to each one of the columns. So we can see, for example, if a column is wrong, and then we can fix this for this specific column. And we're creating this for each one of the models we have just created. And by the end of this, we're gonna use another model called AGG validation, which is aggregation model, where we have all the models that we have just migrated. So we can see in a unique view all the models, all the matches, and we can see this for different timestamps. For example, let's assume that today you finish your migration, you had 100% match, and then tomorrow you run something and you got like a 80% match. So you can check and we can see this snapshotted by time and check results for this. And this is a simple macro we have created, and then we just add this depend zone so we can run this model and check. And here I have just run the models using the terminal. I'm using dbt MCP as well to show the results. And then I'm gonna see if everything is okay and then move to the next task. Now I'm running the last aggregation model, and then the agent's going to run the DBT show again and check the results, see if we have a perfect match. And yes, we have a perfect match, 100% validation. And then this is our definition of done. We can move to the next task. And the last one, the most important one, it's use DBT MCP and build everything, compile everything, run everything, test everything, and then have this migration completed as 100% as possible. So yeah, let's move to the last task. I just prompt here, execute the last task. It's calling our MCP again to verify the last task and then execute this. And as I said, we're gonna run dbt build, we're gonna run dbt test, and then validate that all the models we have just created are good and are good to go to production, open a pull request, and then move this to production. So we're gonna call dbt build, we're gonna call dbt test, check if the models are completed okay, and then we can move this to production, open a pull request, and then close the day and have this done. I'm gonna speed this up so we can check the results. As you can see, dbt build is already completed. Now it's calling dbt test, and after that, I think we are good. That's it. We have the task completed. As you can see, we have the summary. We created all the models. So the models are with the perfect match when compared to the legacy ones. And we can close the day and finish this migration. Okay, I hope you enjoy our demonstration. And to illustrate this, we have a use case. We have this public use case from our minerals, and we have been implementing this today in this agentic workflow, the idea to use agents to migrate from, in this case, from PySpark notebooks. They had like around 400 PySpark notebooks that needed to be migrated to dbt. And we did this for them. It was like our first use case using agents and using AI to do this, and it was a success, right? We could have like a really gain of productivity in this case. So in the beginning, without AI and without like using artificial intelligence for this, we were taking around 45 hours to migrate one pipeline to dbt. When I say one pipeline, it's like a Mars table, or like a gold table in this case in PySpark notebooks, and all your dependencies like bronze and silver tables for this. And with this workflow using AI and like with responsibility, right, we achieve it 7 times faster. So we reduce it from 45 hours to 6 hours, which was huge. And even we had a reduction in time, not in time, but in team dependency as well. So we didn't have to go to the client, like make interviews to understand the models. We could translate this with LLMs really quick with this approach. And also with all the guardrails we have created, we achieved a way better code conformity as well. So around 99%. You can read the full case here. I think you can find the link here in the comment sections. And guys, that's all I have. Thanks for the opportunity. I invite you guys to read our AI readiness report. You can find this also in the comments here and also in our website. And please feel free to reach out in LinkedIn or other social media that you guys can follow us. And thank you again. And Tom, it's with you. Back to the stage. Thank you, guys.
Wow, thanks so much, Igor, for that presentation and demo. I really liked how you made use of the dbt MCP project execution tools and how you broke down each step of the agent workflow into chunks that you could validate at each stage. Really smart way of building reliable agentic workflows. That was great. There's a lot of work that we're doing to bring more agent workflows to your dbt projects, and can't wait to tell you more user stories about how to use AI with dbt. I've got some next steps for you. If you're interested in learning more about dbt, MCP Server, or getting a dbt platform demo, you can click on the Talk to an Expert button in the upper right-hand corner of Goldcast, and your account team will be in touch. Also, we're launching a survey in chat. We'd really appreciate it if you took that survey for us. We're very interested in getting your feedback on today's presentation. Thanks so much, everyone, for joining us today. Have a great day.